All right, I'm going to talk to you about how to write an equation by using information in a table. And so the first one I'm going to show you is linear functions. And we're only going to be dealing with linear functions and exponential functions. Now, I can tell from looking at this that this is not an example of an exponential function because the numbers, my output numbers, are not getting really big real quickly. Okay, so this is going to be an example of a linear function. So just to remind you, we're going to use f of x instead of y because we're talking about a function of x. And so f of x with linear functions is written f of x equals mx plus b, where m is your slope and b is your y-intercept. That's the point on your coordinate plane on the y-axis where it crosses the y-axis. Okay? So the first thing I'm going to do is I'm going to start off by finding my slope. Okay, I'm going to pick 2 points. It doesn't matter which 2 points you pick. I'm going to pick this point and this point. Okay, and so just as a reminder, your slope is equal to your difference of your y's, or in this case, the difference of our f of x's, over difference of your x's. So I have -3 minus 1. That's the difference of my f of x's, over 0 minus 1, that's the difference of my x's. And again, you got to be very consistent. Since I went from the -3 to the 1, I need to go from the 0 to 1. I have to be consistent with my subtraction for my slope. So -3 minus 1 is -4. 0 minus 1 is -1. -4 over -1 is +4. Okay, so now I know that the slope is 4. So I'm going to be able to replace my m with 4 up in my equation when I'm writing it, okay? So now I know the slope. It's a good idea to go ahead and pick 2 other points just to try them, just to double check and make sure that they work. So again, it's the difference of my y's, or difference of my f of x's. So it'll be 5 minus 9 over difference of my x's. So it's going to be 2 minus 3. 5 minus 9 is -4. 2 minus 3 is -1, which simplifies to 4. So you can see I picked those 2 pairs, I picked these 2 pairs. It doesn't matter which 2 pairs you pick, but anyway, I've got a slope of 4 for both of them, okay? So I know in my equation the slope is 4. The next thing I need to figure out is what my y-intercept is, okay? And there's actually 2 ways that I can figure that out here. All right, let me clean this up a little bit. All right, so I know if you were to graph this, just to show you, 0, -3, there is a point. Well, I know that that's my y-intercept because it crosses the y-axis at 0, -3. So I already know that that's going to be my y-intercept just from looking at the table. However, let's say that this number wasn't given here. So you couldn't tell just by looking at the table. There's a couple of things you could do. One, you could just go ahead and plug 0 in for x. I'm sorry, I take that back. You can plug 1 in for x and 1 in for f of x to see what you get. So I'm going to, oops, that's not my eraser. Excuse me. So again, we're saying we don't know this point. We're pretending we don't know. So I'm going to use this point right here. Okay, so we know f of x is 1 because this is our f of x, right? And we know that x is 1. So I'm plugging in a point here in here because I know my x and my f of x, using the slope we already know to determine what our b is, even though I've already told you it's -3. But this is just a way we can kind of double check, okay? And so 4 times 1 is 4. So I subtract 4 from both sides, and I get that -3 is equal to b, which is the same thing I just showed you here, okay? So what this means is, this means that the linear function, the equation for the, I keep doing that, huh? The equation for the linear function of this table is f of x is equal to 4x minus 3. And that's what we were able to determine based on this table here. Okay, now let's talk about what we can do with that. All right, so I said based on that table, f of x is equal to 4x minus 3. Okay, let's say that I wanted you to find f of um, f of 3. Okay, actually, okay. The reason people use function notation, one of the reasons is I know that this is a function of 3. That's what I'm figuring out. And so that means I'm going to replace x with 3 right here in the equation. Okay, so f of 3 is equal to 4 times 3 minus 3. So f of 3 is equal to 4 times 3 is 12. And 12 minus 3 is 9, so that means f of 3 is 9. Oops, that doesn't look right. So if I just told you y is equal to 9, that gives you some information, but you don't know what x is when y is 9. But if I tell you that f of 3 equals 9, you know that when x is 3, y is equal to 9. That's one of the reasons that function notation is used. Okay, now this is different than if I said that, what if I told you that f of x is equal to 13? Okay. What this means is I'm not saying that x is 13. I'm saying that f of x is 13. I'm saying that when I solve this right here, I get 13 right here, okay? So I'm going to replace this f of x with 13, okay? So this means 13 is equal to f of x minus 3. So to solve it, I add 3 to both sides. So 16 is equal to 4x. Oops. Divide both sides by 4, and I get that x is 4. So what I've really found out is that f of 4 is 13. Okay, so if we know that f of x is 13, that means that f of 4 is 13. So that's the answer to that kind of problem, okay? Now let's talk about if we have exponential functions, okay? See how these numbers start getting really big really quickly? That's how I can tell that this is an example of an exponential function. So what I'm going to do here is, first of all, I want to remind you that exponential functions are written in the form of a times b to the power of x, meaning we do the b to the power of x first because of the order of operations, PEMDAS, then we multiply. Now the tricky part is here that I've got a lot of variables going on here, okay, and I only have this information in the table. I am going to start off with this first point to help me see what I can solve for, okay? And so again, remember this is the same thing as saying f of x is equal to a times b to the power of x, okay? So let me replace what I know, okay? Remember this is f of x, so I'm going to say 2 is equal to, I don't know my a, I do not know my b, but I know that x is 0. So if x is 0, that's what we've done here, then f of x is equal to 2. Now, we know from looking at this that anything to the power of 0 is 1. So this is 2 equals a times 1. Well, a times 1, remember anything times 1 is equal to that number. So this means a times 1 is simply a. And then I've got 2. So this means that 2 is equal to a. This only works if I know that my x is 0. If I used any other point, like let's say I plugged in this one, so we would say 18 is equal to a times b to the power of 2. There's nothing we could simplify here. It's only because of the rule that any base raised to a power of 0 is 1. That's the only reason we can simplify this, okay? So it only works if you know x is 0 and you know your f of x. Can you simplify this, okay? All right, so now that I know that, oops, I did it again. Okay, so now we just figured out, and let me write it in one of my pretty colors. So we just figured out that a was equal to 2. Okay, that means for all of this problem right here, a will be equal to 2. I don't mean every other problem that you're going to do for the rest of your life with exponential functions. I just mean for this particular table, this particular equation, a is going to be equal to 2. Okay, so now we've got it down to knowing that, oops, I did it again. We got it down to knowing that f of x is equal to 2 times b to the power of x. Okay, so our next step is we've got to figure out what b is. So now we can pick a point. I'm going to pick this point, and you'll see why it's going to help because of that b being 1 right there. So 6, our f of x is 6. 2 times b, we don't know what b is, but we know that our x is 1. Well, anything to the power of 1 is itself. B to the power of 1 is simply b, so this is just going to be 2 times b. I can divide both sides by 2, and I get that 3 is equal to b. So now that I was able to figure out what a is and what b is, now I know what the exponential equation is for this table, for this data. And that is that f of x is equal to, my a is 2, times my b, which is 3. Oops, I messed up. Sorry. To the power of x. Okay? This is not the same thing as 6 to the power of x. Remember, you've got to do the exponents first before you multiply, okay? This is not the same thing as 6 to the power of x, okay? So this is going to be the equation for this particular table. So just to kind of give you another example with it, so we said f of x is equal to 2 times 3 to the power of x. And I said, what is f of 3? That's going to be equal to 2, because I'm replacing x with 3. So it's going to be 2 times 3 to the power of 3. 3 to the power of 3 is 3 times 3, which is 9, times 3, which is 27. So this will be 2 times 27. So f of 3 is equal to 54. Now this is different if I said, okay, what if I said f of x is equal to 18? Well, then you would say 18 is equal to 2 times 3 to the power of x. Divide both sides by 2. So 9 is equal to 3 to the power of x. And we know then that x would be equal to 2 because 3 squared is 9. So this means that f of 2 is equal to 18. Okay?